as well too. And it says specifically to find the slope given standard form equation. This is only good for a standard form equation. Hopefully that'll help you remember it because it's capital A and capital B, and that's the only place you see that in what we're dealing with. So it's not good for other types of equations. You don't flip the sign when you're doing, slope-intercept form. No, this is just, you only flip the sign here for standard form because you've moved that, if you were solving for y, you'd be moving that ax over to the other side, which flips its sign. Okay? So if you've got a standard form equation, just put your a over your b and flip the sign. Now that means you've got something consistent going on here. If I've got a negative, a subtraction standard form, am I going to have positive or negative slope? Yeah, and if I've got plus going on in my standard form, I'm going to have negative slope. That'll be something the more you practice, take note of those little things, those little consistencies. Okay? But using the formula, for this one, I do m equals, and I just draw, automatically, I draw a negative sign and a fraction bar. Okay? And then what's my a? Okay. And what's my b? Negative 2. Be very careful about that. So my slope is, okay, and because that was the negatives canceled out. Okay. And here, the slope, I just draw a negative sign in my fraction bar. So I'm consistent. Put my a over my b. What's my a? And my b? And so my slope is negative 5. And there was a subtraction standard form, I ended up with a positive slope. Addition standard form, I end up with a negative slope. But it still comes back to that just little formula. Yes? Oh, yeah, okay. Now, graphing purposes, before I jump into the horizontal and vertical just to finish things off, graphing purposes, what do you know about this line?
Or down.
Yeah. So you're expecting that downward line. Yeah. Diagonal, kind of shallow. Where are you going to plot your first point when you graph this?
Just at 0.
Yeah. See, there's no b. There's no constant. There's your x and your y. Ooh, diagonal. There's no constant. Goes through the origin. Okay. Here, where do I plot my first point?
Negative.
On which axis?
The y.
0, negative.
Yeah, the y-axis, 0, negative 6. And then count my slope, 1 over 1, 1 over 1. So, and then if you wanted to find the x-intercept, which you'll be asked for, you plug in.
Oh, wait, say it again?
The definition of the x-intercept is when
Y equals
0, right. The definition of the y-intercept is when x equals 0. Okay. The definition of the x-intercept, which we can easily find just because we know that's our b. But the definition of x-intercept is when y equals 0. So you have to plug in y equals 0 and then solve for x. So you have to do a little math to find the x-intercept, either because I ask you to find it or to do it just to check your work. Okay? But to graph this, y-intercept and slope, boom, it's graphed, no math needed. Plug in y equals 0, you got the x-intercept also. Okay? Now here, the easiest way, you've got the slope with that little formula, okay? But the easiest way here, remember, is to find your two intercepts. In standard form, 3x minus 2y equals 9. Okay? I find a lot of students have trouble with this. They forget it, or they're making it more complicated than it needs to be. So remember, in standard form, you need to graph a line. You need either a point and a slope, like here, y-intercept and slope, boom, it's given to you. Or you need 2 points. Standard form, the easiest way, boom, I need to get 2 points. Let's get my 2 intercepts. Now, intercepts are just, the definition of a y-intercept is when x equals 0, and the definition of a y-intercept is, x-intercept is when y equals 0. So this is like making a little table of values, but it's not a big tedious table of values. Because it's in this form, we can use cover-up. Instead of like plugging in and calculating, cover-up is just a quick little way to do a plug-in and table of values. If x equals 0, what happens to 3x? So literally cover it up. This is like plugging in x equals 0, but I'm covering it up, physically covering it up with my thumb. And then write down what you see and solve for y. And so when x was 0, y is, now these directions are on that graphing handout too, but I just wanted you to see it in practice because we were a little rushed at the end of the class I did this in. Now if y equals 0, now notice when I covered up x, don't cover up the sign in the middle because that's a -2. So you cover it up because it went away, write down what you see, and finish solving for y. If y equals 0, -2y physically goes away. It's like plugging in y equals 0. But I'm not messing with my calculator or anything more complicated than that. Write down what you see and finish solving for x. Divide both sides by 3. So that gives me the point when x is 3, that was because y was 0. And boom, you have 2 points. Now if one of the points is a little messy, or you just want to check your work, or you were asked, then you get the slope. You can either graph the 2 points and check with the slope, or check the nice pretty point and the slope, and then, check that it went, -4.5 isn't too hard to graph. Okay? But if it's a really ugly fraction, you might want to use the clean one, the clean intercept, and the slope. Okay? You need 2 of these things to graph. You've got 3 of them. And I'll ask you for all 3. You can choose how you want to graph it, with which 2. Okay? Now, what do I know about this one? Do I need to do cover up for this one? If I did, 5x plus y equals 0.
Maybe it's just
Yeah. This line goes through the origin for both. And I knew that without doing cover up because, the constant is 0. Just like over here, my little b, which is my constant, is 0. In this form, my constant is big C, but it's still 0. If the constant is 0, your line goes through the origin. Okay. So this is a little rush, but we finish up with the horizontal and vertical, and it is in that handout as well. Okay. But I'll scan this in as well, so if you get some extra practice there. I'll also, when I scan this in, I'll go ahead and graph these lines. So if you want to graph them as extra practice, you can check your work. Okay, so to finish up, x equals 3, -5x equals 25, f of x equals -4, and 2y minus 3 equals 7. What kind of line is this?
vertical.
This one?
Also,
Do you see an x and a y, or just one or the other?
just one of
Just an x, yeah. If it only has an x, it is vertical. What about this one?
also. No, the f of x, can it equal y?
Yes. In fact, to make it easier for your eye to look at, just write y instead of f of x. Okay. And this one? Your eye wants to think that's diagonal because it looks almost like it's in, one of the pretty forms almost, but there's no x there. Don't think I made a typo and try and stick one in yourself, okay? There's just a y, there's just a y, and that means these are horizontal. Okay. Now, it's very important when you see, can I write, you can see how this one can be written, once you solve it for y, it can be written in function notation. If you remember from 8.2 from last week, that means that these are functions. These are horizontal lines, and they are, just like diagonal lines, they are functions. Okay? You draw a horizontal line, it passes the vertical line test. Okay? No x is used more than once. Okay? What about a vertical line? Is it a function? No. It fails the vertical line test because it is a vertical line. It's still a relation. You can still graph it and know stuff about it, but it's not actually a function. Okay? And how could you solve it for y? There is no y, right? Okay, so in order to graph it, though, you do need to put it in this form. It needs to be in the form, standard form for a vertical line is x equals c. Okay? Standard form for a horizontal line is y equals c. All this means is solve it for x or solve it for y. Okay? So to finish up, you've got that piece of graph paper. And let's go ahead and show. Once you know this, it's really easy to graph these lines. Don't overcomplicate horizontal and vertical lines, but it's just about understanding their characteristics. Once you have that, they're super easy to graph. Okay? So we'll start with x equals 3. Now, x equals 3 literally means that. You remember looking at those points like we were doing slope. It doesn't matter what y is, x equals 3. So I'm going to put 3 where? Yeah. There's infinite points, but to graph a vertical line, I only need one of them. Put that right there is your x-intercept, x equals 3, but it also means x equals 3 no matter what y is. So now I just draw a vertical line through x equals 3. And then when I'm asked slope, x-intercept, and y-intercept, what's the slope?
0.
Undefined. Not 0. Careful about that. Yeah. Slope doesn't exist. You can't walk on it. Boom. Hit the wall. What's the x-intercept?
3.
It's always what your c is, but write it as an ordered pair.
So 3,
0.
Right. Oh, the intercept is an ordered pair. This just tells you where it crosses the axis. Your c will be part of that ordered pair. And your y-intercept? Yeah. Does it cross the y-axis? No. So just none. Now if you have, let's say negative 5x equals 25, are we ready to graph that? Yeah. We have to solve for x first. Okay. So I'll divide both sides by negative 5 and get x equals negative 5. Now I'm ready to graph because it's in standard form. And I know all the information I need to know about it. The equation itself tells me where to put a dot. X-axis, negative 5. Because it only has an x, I know it's a vertical line, so that's all I need. Draw a vertical line through that spot. What's its slope? Yep. What's its x-intercept?
Negative 5, 0.
What's its y-intercept? None. So super easy to fill in this information and graph them. Is more about understanding the characteristics and the concepts. Don't overcomplicate it. This is what you need to know about a vertical line. Don't try and stick a y in there, make it something it's not. Okay. So I've got 3 minutes left, so let's look at the horizontal. It's the same idea, that same rhythm. So let's do, if you've got f of x equals negative 4, for graphing purposes, go ahead and write it as y equals negative 4. Okay. Oh, yes, there you go. Okay. So go ahead and graph that and tell me slope, x-intercept, and y-intercept.
Slope 0. There is no
The very name of this line tells you where to graph it. Y equals negative 4. And you know it's a horizontal line, so that's the only point you need. Slope is
0.
x-intercept, y-intercept, right, as an ordered pair. And 2y minus 3 equals 7. You must put it in standard form first. You see it's a horizontal line because it only has a y, but you need to solve for y, and then that tells you everything you need to know. And one last thing I want you to consider. What is, any questions on that? I know I went really fast through that, but that characteristic is the same thing. Same thing for everyone. Put it in standard form. Solve for x or y first, and then you know the characteristics of the line, and the equation itself tells you where to put the line. And just to tie this back to the functions we did before, well, functions and relations is domain and range. Let's look back just to that first vertical line, and tell me the domain and the range. What is the domain? All the possible x values that this line can be.
There's no domain.
Oh wait, no, I mean.
There is a domain,
Well, it's just 3.
just 3. Yeah, all the x values. Every point is going to have a -3, a +3 in it. That's it. So where we said with continuous graphs you want to use interval notation, remember this one's the exception. If x can only be 3, then we can just list it in set notation. Okay? The only possible x values in this graph are 3. What's the range? What are the possible y values?
Negative infinity, something.
Right. And then the domain and range of this line. Domain, all the possible x values.
Negative infinity.
And what's the range of a horizontal line?
Just -4.
Yeah, it's whatever c is in this case. -4. The only y value that this will ever be, the very nature of the line itself is, and we use set notation because it's just a single number, -4. Okay. Right on time. It's also, if you got questions, I know that was kind of a rush, this will also get scanned in, and in 10 minutes I'll also be downstairs in the lab. If you want to come work more on some of this graphing, and the homework for today is going to post like within the next hour. Okay. And all of this is also covered in a little more detail too, remember, in this Graphing 101 handout.